In this video, we're going to start discussing industries based on commodity chemicals, and we're going to start with alkali metal salts that are common in industries. So the first salt that we will discuss is sodium chloride. This salt is very common and it occurs in huge amounts as deposits of pure sodium chloride, sometimes have impurity of clays and different types of debris and quartz and different minerals. So the whole process of producing sodium chloride includes purifying the deposit from debris, and the purification can be done using two methods. First one is by gravitational separation from a saturated solution of sodium chloride. So you use the difference in specific gravity between the salt and the impurities to clean up the salt from different impurities that are typical in such a salt. And second procedure is by leaching using brine solution. So it's going to be dissolving the deposit and then recrystallizing the deposit again in a more pure form, leaving the impurities behind. It is possible to extract sodium chloride from seawater. It's typically done by sequence of concentrating the seawater sample using solar evaporation on a multi-stage. Each stage will have concentration suitable enough to precipitate one type of the impurities. And it's going to precipitate the different salts in the seawater solution based on their solubilities. Calcium salts are usually very insoluble, like calcium sulfate and calcium carbonate. So these precipitate first, and then you take the mother liquor, you move it to a second crystallization plant where you can isolate sodium sulfate, which is of industrial importance by itself. So it can be produced and sold. But then after you crystallize out all the sodium sulfate, the mother liquor will have very high concentrations of sodium chloride that can be crystallized out and produced and purified in successive steps. The whole target of the purification is remove impurity cations like calcium salts as well as sulfate ions from the sample. You can get rid of these as insoluble precipitates by adding certain reagents. If you add calcium hydroxide, for example, it's going to get rid of any remaining impurities of magnesium ions. And then the remaining calcium ions can be precipitated as calcium carbonate by adding sodium carbonate into the mother liquor or adding carbon dioxide directly from furnace gases. And sulfate can be removed by concentrating the solution to the point that sodium sulfate precipitates out and leaves the mother liquor free of sulfate ions. It's typical that 1 cubic meter of seawater gives around 23 kilograms of sodium chloride. The second sodium salt of industrial importance is sodium carbonate, and that can be produced typically from natural deposits. And the most important mineral containing sodium carbonate is this mineral right here, which is a co-crystal of sodium carbonate and sodium bicarbonate. The production goes through two different processes. In the monohydrate process, the mineral is first calcinated at high temperatures, dissolved in water, and then filtered to remove any insoluble impurities, and then evaporated to dryness to produce the carbonate monohydrate crystals. The sesquicarbonate process, you dissolve the mineral in water, free it from impurity, then calcinate it. The process starts with the mineral. You take it through grinding and sieving steps, and then you calcinate it in hot furnace tubes, and then you dissolve it in water. Take the mother liquor into concentration and purification steps, then filtration to remove any insoluble impurities or organic impurities using charcoal filters. And then you take the filtered mother liquor through a crystallization step to produce the carbonate monohydrate that you can then centrifuge to isolate and dry package for production. Second process to produce sodium carbonate is the solvay process. In this process, you start with sodium chloride starting materials, and it depends on the pore solubility of sodium hydrogen carbonate compared to sodium chloride. So once you mix sodium chloride with ammonium bicarbonate, the sodium bicarbonate is much less soluble than anything else. So you precipitate the bicarbonate as the sodium bicarbonate precipitate, and then you can decompose the bicarbonate into the carbonate form in a later step. Ammonium bicarbonate reagent is produced by passing ammonia into concentrated solution of the sodium chloride, then saturating the solution with carbon dioxide. Once you do that, the sodium hydrogen carbonate will precipitate and it's going to deposit. Then you can calcinate it in order to decompose it into the carbonate form, which is going to produce carbon dioxide again. So carbon dioxide and ammonia, which can be recovered from the ammonium chloride byproduct, can be recycled back to the reactor again, which makes the overall reaction a reaction between sodium chloride with calcium carbonate, producing sodium carbonate and calcium chloride, making this a very efficient production process. Here is a flow chart summarizing the whole process. You start with the raw material of sodium chloride. In a solution, you mix it with both ammonia and carbon dioxide to produce the ammonium bicarbonate in situ. Once you make the ammonium bicarbonate, it's going to react with the sodium chloride to produce sodium bicarbonate deposits and ammonium chloride byproduct, which can be reacted with calcium hydroxide to regenerate ammonia again to be recycled. And the sodium bicarbonate deposit, once you heat it up, is going to decompose into the sodium carbonate product and produce carbon dioxide again, which can be recycled back to the process. So the reactions that take place in this process within the solvate tower is going to be a reaction between the ammonia gas and carbon dioxide gas and water to produce ammonium carbonate. Ammonium carbonate reacting with excess carbon dioxide and water is going to turn into ammonium bicarbonate, which then is going to react with the sodium chloride solution to make deposits of sodium bicarbonate. And byproduct of the ammonium chloride, the calcium carbonate can be heated to produce calcium oxide and carbon dioxide that can be recycled into the previous step. Calcium oxide and water can produce calcium hydroxide, which can be used to recover ammonia again. The reaction in the calciner is going to be the decomposition of ammonium bicarbonate into ammonium carbonate and carbon dioxide that can be recycled to the solvate tower reaction medium. And within the ammonia recovery tower, ammonium chloride reacts with calcium hydroxide to recover ammonia that can be recycled back to the reaction medium, as we said. Sodium carbonate is one of the most important industrial chemicals. It's a very big component in glass industry, where it serves as both a raw material and a flux material for the glass melt to dissolve the sand. And it also is used in the manufacture of different chemicals, other salts of sodium like sodium phosphates, silicates, chromates, dichromates, hydrogen carbonates, nitrates, and so on, that are used for other purposes. It also can be used in the soap and detergent industry, and small quantities are necessary in almost every industry throughout the chemical industry in general in order to scavenge sulfur oxide and nitric oxide out of the exhaust smokes of different industries. The third form is sodium hydrogen carbonate or sodium bicarbonate. This is produced by reacting the filtered solution from the sodium carbonate process with carbon dioxide with cooling. This is going to convert any remaining sodium carbonate into sodium bicarbonate. And sodium bicarbonate or sodium hydrogen carbonate precipitates out in this case. And it has applications in the food industry, specifically for producing baking powder, in the rubber and chemical sectors, textile, paper, leather industries, for different processes during the industry itself, in the production of a lot of pharmaceuticals, fire extinguisher powder, and animal feed stuff, used as neutralization agent for the manufacture of soaps and detergents. Next, sodium sulfate. We already quickly mentioned that it has lower solubility than other sodium salts. So when you start from seawater, it's going to actually crystallize out first. So that's the major production of sodium sulfate is crystallization out of seawater within the whole crystallization process that we described before for sodium chloride. It's going to actually crystallize before sodium chloride. And it's also produced in large quantities as byproducts in a lot of chemical industries and metallurgical processes. For example, in the production of sodium dicarbonate, vitamin C, formic acid, resorcinol, and fibers. Also formed as a byproduct in the manufacture of hydrogen chloride when you react sodium chloride with sulfuric acid. So you will automatically produce sodium sulfate as a byproduct. This is a very important industrial salt because it's used as a filler for detergents. It's used for clarification of glass and also for treatment of textiles and as an electrolyte for electroplating purposes. The next sodium salt of industrial importance is sodium borates. Those are typically produced from this list of minerals right here. And the production involves extraction by dissolving the mineral with heating in a borax containing mother liquor, and then you separate the impurities off and crystallize the sodium borate out of the mother liquor after purification. It's also possible to produce it from the calcium sodium borates by heating with sodium carbonate or sodium hydrogen carbonate. The calcium carbonate will precipitate out and leave a solution of sodium borate that can then crystallize out. It's typically used as a flux to reduce the thermal expansion of glass during the glass manufacture, and it's used in a lot of metallurgical purposes, also as a flux during the welding and soldering, and it's a component in a lot of ceramics, enamel, and glass fiber porcelain industries.